Let's just display the third option, and that is to have a magnet on the top. That is what we have been using when we sell 18650s and people want button top. A magnet is really good because you can remove it, and for low drain it actually works pretty good. But I think all of these three options are decent. Magnet and solder are super cheap. This one will cost you less than $1 to add, but still takes a lot of time to prep. So how will we test which is better? Adding a button top, adding a bit of solder, adding a magnet. The best way to do this, I thought, I will test one cell 4 times with different kind of tops. First I will test them without anything, and since it's easiest to add a magnet and remove it later, I will add a magnet. After that I will create a button top because it can be removed, and after that I will use a solder blob to see which method actually is the best. And I will use one of these ZKE racks which has very good conductivity to the cells, and I will use a very precise tester and we will compare. It will not be perfect, but it will give you a hint if any of these methods are poor. Personally, I think the magnet is the worst, partially because magnets themselves are very poor conductor, and these are just plating, nickel plating probably, but it's only like 0.001 or so. Plating is very, very thin and it won't help conductivity that much at higher amps. And I think I might be safe testing this kind of cell at 5 amp. I don't want to go higher than that. Yeah, never been tested before, still has factory voltage. So I will start with charging this up. We can also do some testing in the MC3000, but it only goes up to 2 amps per slot. It will take some time, but I think this will be a more accurate test. Now I have charged this cell fully on the little collar and inserted this to this holder and connected everything. I have a low voltage cutoff at 2.8 volts and we're running it at 5 amps. This cell should be able to handle 8. So let's see. And now we're running without... Okay, this cell couldn't even handle 5 amps. Okay, let's go down to 4. So why did this Samsung cell not be able to handle 5 amps? That's a little strange. So I'm gonna check where the drain is, if it's the actual cell or if it's any of the wiring. It works, it works. But now it's not working, so I'm gonna do this test on 3 amps and I'm gonna start and I'm gonna see where the voltage is dropping off. Let's try and measure on the actual cell. The actual cell is 4 volts. So that's not the problem. Let's measure. Okay, I have to go down to 2 volts for it not to just close down. Let's see if it's the connection point here. No, that's also holding pretty good. Is it the wire coming out? There is a little bit of a voltage drop between this part and this part. Let's see, this part. Then we go down to the connection here. There's also a little bit of a drop. Then we have Mr. Crocodile, 3.85. Let's see, Crocodile number 2, 3.58. So the big drop is between the Crocodile and this part. So let's measure here. Crocodile and bottom, 3.63. So we're gonna have it here and then we will check the screw. And there's also a problem on the screw. Where does it go then? It's a pretty thin wire and it's long to travel, because here we have pretty good voltage, very close to the actual cell. Not exactly, but and this is supposed to be for high amp draws, but it can't even handle 3 amps without real significant droppage. So the only way to actually test this would be to add crocodiles on these clamps, because these terminals, I don't know how the positive goes from over here. It says positive here, so I guess there is a bus bar or something built into this. The negative we can see come with a wire, and it has dual wires because it's able to measure amps as well. And I have connected them in the voltage output, which I assume are good. Let's just see what the amp positive says. Maybe you should connect both of them to be able to measure higher amps. So let's have the negative side, and we'll see all the voltage drop here, 3.68. Here we actually have a good reading, even better than on that side. So let's connect this one in the amp positive. So let's run this again. Now we have a lot better voltage. That's, let's see, actual cell, and in the clamps 3.96. So we have some losses going down here as well. 3.95. It's a little higher in the amp slot, so I will connect it to the amp slots. I'm guessing that's how you're supposed to do it. I don't know if this came with a manual, but if you insert them in the voltage, it will just go down to 0. I'm not going for 0 resistance or anything like that. I just want a good baseline so I can compare the cells with different tops. So if there's a little resistance in the system, it doesn't matter as long as it is the same with all the tops I'm gonna be testing. So let's go again. 4.04, 4.01, that's good. The clamps 3.99, and incoming 3.95, on the display 3.95. Now we're actually ready to test, and it wasn't the Samsung cell that couldn't handle 5 amps. It was these terminals for some reason. I don't know. But it's good enough to test, so I'm gonna charge this up again, and we can do the test at 5 amps. So I've done some modifications to the rig and the clamps and everything. The cell is now fully charged again, and we're gonna test it at 5 amps as we originally intended, and hope it works better this time. That looks a lot better. Still dropping some voltage, but that's to be expected at 5 amps. So now we're at the end of the test. Cell isn't even hot. And what did we get? 2.65 amp hours, 8.9 watt hours. Now we will charge this up again and try it with a magnet. Keep going until we know which method is the best.